Dear students, let us see 9th class 15.4 mathematical proofs in that fourth exercise. Before we go into this exercise, let you know some statements that the sum of three interior angles of triangle is 180 degrees, as you know already and you proved, and the product of two natural numbers is odd. And the product of any two consecutive even natural numbers is divisible by 4. Now let us see 15.4 first question what they asked. State which of the following are mathematical statements and which are not. Mathematical statements means it should have mathematical symbols, numbers. Okay, then we can say it as mathematical statement. First one, she has blue eyes. It is not having any mathematical symbols or numbers, then it is not a mathematical statement. X plus 7 is equal to 18. It is ambiguous, mathematical, okay, but it is ambiguous sentence. Next, today is not Sunday. It is not a mathematical statement because there is no math in this sentence. For each counting number x plus 0 is equal to x. This is a mathematical statement and which is true. Next, what time is it? This is not a mathematical statement. Then let us go into second question. Find counter examples to disprove the following statements. Whatever we give examples for the given statement to be not true, those are called counter examples. First sentence, the statement they have given, every rectangle is a square. They have given every rectangle is a square. But we know that a rectangle in which two adjacent sides are equal is a square, not all rectangles. Okay, here we have to give counter example that a rectangle in which two adjacent sides are equal is a square. That is the answer. Second one, for any integer x and y, root x square plus y square is equal to x plus y they have given. Now let us take any two integers of x and y. Here we have taken x2 and y3. Let us substitute in the given. Root x square plus y square is equal to root 2 square plus 3 square means 4 plus 9 root 13. And x plus y if you take RHS 2 plus 3 5 and both are not equal. Therefore, this statement is not true for this. That means here x is equal to 2 and y is equal to 3 are counter examples for this statement. Then see the third one, what they have given. If n is a whole number, then 2n square plus 11 is a prime. Let us substitute n value, any one, our wish. If you substitute another values, it may be true, but for n is equal to 1, if you substitute 2 into 11 square plus 11. In the given expression, we substitute 2n square plus 11. N place 11 you have to substitute. 11 square, 121 into 2 plus 11. It gives 253 and it is not a prime number. Okay, 253 is not a prime number. And they have given in the question that 2n square plus 11 is a prime. Therefore, we can say given statement is false for this n is equal to 11. Therefore, n is equal to 11 is the counter example. Let us see the fourth one. Two triangles are congruent if all their corresponding angles are equal. Two triangles congruent అవ్వాలంటే మనం ఏం చెప్పుకున్నామండి, all corresponding sides should be equal. But here they have given only about corresponding angles. Then we have to write that two equilateral triangles with different sides are not congruent. Here they have given two triangles are congruent. Okay, corresponding angles are equal. Corresponding angles equal అయితే congruent అయిపోతాయి అని చెప్పారు. We know that in two equilateral triangles corresponding angles are equal. అన్నిట్లో 60 60 60 ఉంటుంది. కానీ two equilateral triangles with different sides, ఒకటి 3 cm side ఒకటి 5 cm side ఉంది అనుకోండి, then they will be not congruent, no? That's what we have to give as counter example. Okay, next see the fifth one. A quadrilateral with all sides are equal is a square. And we know that a quadrilateral with all sides equal is a rhombus also. That's what we have to give counter example. Rhombus is also a quadrilateral with all sides equal. Let us see the third question. Prove that the sum of two odd numbers is even. Odd numbers, two odd numbers add చేస్తే ఈవెన్ వస్తుందని ప్రూవ్ చేయమన్నారు. For that we cannot take examples. We have to take general form of odd number. General form of odd number is 2n plus 1, because if you multiply with 2 that becomes even number. If you add 1 to even number that becomes odd. Then general form of odd number is 2n plus 1, and let the two odd numbers be 2m plus 1 and 2n plus 1. Two odd numbers we have to take. Then their sum, let us see. 2m plus 1 plus 2n plus 1. From these two terms we can take out 2 common, then m plus n. 1 plus 1 becomes 2. From these two again 2 common into m plus n plus 1. 2 came out now, 1. Then m plus n plus 1. If you consider as any number together, 2 into is there. 2 into something means it will be even, compulsory. Therefore it became even. Then the sum of two odd numbers is even, hence proved. Now see the fourth one. Prove that the product of two even numbers is an even. Even numbers. Even number general form is 2n. Let us take two general numbers. The general form of even number is 2n. Then let the two even numbers are 2m and 2n. Their product we have to find, 2m into 2n. Then from these two, 2m into 2n. 1, 2 we have written separately, m into 2n as it is. Then these two will be as it is, this will be 2mn. In place of 2mn, if you write any alphabet p, this means 2 into something is there. 2 into something means it will be even. Therefore the product of two even numbers is an even number, hence proved. I hope you are understanding. Please follow this procedure and learn. And fifth question is to prove that if x is odd, then x square is also odd. Let us take one odd number, x. X is odd. Then odd means general form 2n plus 1. They asked to prove that x square is also odd. X odd we have taken, x square we have to find out. X square means 2n plus 1 whole square. A plus b whole square. A square 2 square 4 n square plus b square 1 square 1. 2ab 2 into 2 4n 4n. Then here if you take out 2 from these, because we have to prove odd and prove చేయాలంటే 2 into something plus 1 and prove చేయాలి కాబట్టి 2 కామన్ చేస్తాం వీలైన వాటిలోంచి. 2 if you take out, here remains 2n square, here remains 2n. This plus 1 as it is. Then 2 into something, that something is written as p. 2 into something plus 1 means it is an odd number. That means if x we take odd, its square also become odd. Therefore if x is odd, then x square is also odd, hence proved. Last question, sixth question is examine why they work. Given statements why they are true, we have to check. Choose a number, double it, add 9, add your original number, divide by 3, add 4, subtract your original number. They have given step by step procedure what we have to do. What is your result will be 7. Whether it is true or false we have to check by taking a general number. Let us take number is x. They asked to double it, means 2x. They asked to add 9, 2x plus 9. Next they asked to add your original number, means 2x plus 9 plus original number is x. 2x plus x, 3x plus 9. And they asked to do next to divide by 3, then total divided by 3. Then if you take out common 3 here, x plus 3, 3 will get cancelled, remains x plus 3. Then ask to find add 4, then x plus 3 plus 4, it will be x plus 7. And next we have to subtract the given number, subtract original number, means x plus 7 minus original number is x. X will get cancelled, 7 remains. The answer is 7. That's what they have given. The result is 7. Yes, it is true. Next, second one, they asked to write down any 3-digit number. For example, 425. Make a 6-digit number by repeating these 3 digits. Like this, 425, 425. Your new number is divisible by 7, 11 and 13. Whether it is true or false, let us check. See, they asked to take 3-digit number. I have taken 124, 124. Then 6-digit number will be 124, 124 by repeating the same number. 6-digit number. Let us see whether it is divisible by 7, 11 and 13. 124, 124 divided by 7 is this one. Remainder became 0. By 11, quotients are there. Therefore, this number is divisible by 7, 11, 13. Remainders are zeros. Therefore, given statement is true. I hope you are all understood and do your best in your exams. Prepare well. Thank you.